Inverse functions. An inverse function effectively undoes what a function has done. So if we start with x and we substitute it into the function f of x, then the output is f of x. So f has taken x and done whatever this function does to it. The inverse function for f is denoted by f negative 1x, but note this isn't an index, it doesn't mean 1 over f. Because it's the inverse function, out comes x. Now note, these are inverses of each other. So if you start by substituting x into the inverse function, out comes f negative 1 of x. If you then substitute that into f undoes what the inverse has done, and out comes x. You could just simply switch where the negative 1 is on these two functions. They are inverses of each other. Formally, we would write that f of f negative 1 of x is x, and of course you can do that the other way around. For a function to have an inverse, it must be a one-to-one function. Recall, this means it must satisfy the horizontal line test. So this function here would satisfy the horizontal line test. Any horizontal line drawn across this graph would cut at most once. Whereas this function is a many-to-one function. If I draw a horizontal line across here, we can see it cuts twice. As soon as it cuts more than once, we know that we have a many-to-one function. So this function here could not have an inverse. However, we can make a many-to-one function into a one-to-one function by restricting the domain. So take this quadratic for example. We can see at the moment it's many-to-one. If we have f of x is x squared, where x is any real value, that's a many-to-one function. However, if we then restricted the domain to just x is greater than or equal to 0, it would be a one-to-one function. If we'd made this restriction, we would lose this limb of the graph. And then any horizontal line would only cut once over here because this part would no longer exist.